Hello, today we are going to learn what is in vitro dissolution, what exactly is a dissolution rate, and what is viability. Myself Prashant Naik. The physiochemical property of most of the drug has great influence on the absorption characteristics from GIT in dissolution rate. The best way of assessing therapeutic efficacy of the drug with the slow dissolution rate is the in vivo determination of viability, which is usually done whenever a few formulation is to be introduced into the market. However, monitoring batch-to-batch consistency through the use of such in vivo test is extremely costly, tedious and time consuming. Besides exposing the healthy subject to hazards of drugs, it would therefore be always desirable to substitute the in vivo viability test with inexpensive in vitro methods. Simple in vitro disintegration test is unreliable. The best available tool today can be at least quantitatively assure about the biological availability of a drug from its formulation in an in vitro dissolution study. Now, in vitro dissolution testing models. For an in vitro test to be useful, it must predict that in vivo behavior to such an extent that in vivo viability tests need not be performed. Despite attempts to standardize the test performance, the in vivo dissolution technique is still by no means a perfect approach. The efforts are mainly aimed at mimicking the environment offered by biological system. There are several factors that must be considered in the design of a dissolution test. Factors are dissolution apparatus such as design, size of the container, how much ml or liter, shape of the container, round bottom of flask, nature of agitation, stirring, rotating, oscillating, speed of agitation, performance precision in the apparatus, etc. Now the factors related to the dissolution fluid such as composition, water, HCl, phosphate buffer, gastric simulated fluid, what should be used? Viscosity should be checked, volume, larger than the needed to completely dissolve the drug under test. Temperature is a very important point which should be 37 degrees centigrade and maintain a sink condition. Non-sink condition gradually increases drug concentration in the dissolution medium. Sink condition, the drug concentration solution is maintained at constant at low levels. Process parameters such as method of introduction of dose, form, sampling technique, changing the dissolution fluid, etc. Now, what are the ideal features of a dissolution apparatus? The fabrication dimension, positioning of all components such as precisely specified and reproducible run to run. Apparatus must be specific, simple in design, easy to operate, and unusable under a variety of conditions. Apparatus must be sensitive enough to reveal process changes and formulation difference, but still yield repeatable results under identical conditions. Apparatus in most cases should permit control variable intensity of mild uniform non-turbulent liquid agitation. Nearly perfect sink conditions should be maintained. Apparatus should provide an easy meaning of introducing the dosage form into dissolution medium and holding it once immersed in a regular, reliable fashion. Apparatus should provide minimum mechanical aberration to the dosage form during the test period to avoid disruption of microenvironment surrounding the dissolution form. Evaporation of the solvent must be eliminated. Medium must be maintained at a fixed temperature within a specified narrow range. Most apparatus are thermostatically controlled for 37 degree. Samples should be easily withdrawn for automation, manual analysis without interfering between the characteristics of the liquid. Apparatus should be capable of allowing the evolution of disintegration non-integrating dense or floating tablets or capsules or finely powdered drug. Apparatus should always good interlaboratory arrangement. Dissolution approach has evolved gradually and considerably. Simple beaker type, highly versatile and fully automated instrument. Device can be classified in a number of ways based on the absence or presence of sink condition. There are two principal types of dissolution apparatus: closed compartment apparatus, open compartment apparatus. Third one is called dialysis. The first one, closed compartment, basically a limited volume. Closed compartment, basically a limited volume apparatus operating under non-sink condition. Dissolution fluid is restrained in the size. So restrained the container, size of the container. Beaker type apparatus such as rotating basket and rotating paddle apparatus. Open compartment apparatus, it is one of the which dosage forms is contained in a column which is brought in continuous contact with the fresh flowing dissolution medium. Perfect sink condition. Third type is dialysis, poorly aqueous soluble drug in which maintenance of sink condition would otherwise require large volume of dissolution fluid. Once the off trial or compendial methods which are discussed here briefly. Now, what is rotating basket? First type, described by Parnaraki et al. It is basically a closed compartment beaker consisting of cylindrical glass vessel with a hemispherical bottom of 1 liter capacity, partially immersed in a water bath to maintain temperature of 37 degree. The cylindrical basket made up of a 22 mesh to hold the dosage form centrally in the vessel at a distance of 2 cm from the bottom and rotated by variable speed motors through a shaft. Basket but remain in motion during the drawing of sample. All metal part like baskets and shaft are made up of 36 steel grade of 316. Rotating paddle type, second one. Assembly is same that of one. Instead of rotating basket is replaced by a paddle. Stirrer type of things, first described by Levy and Hayes, and the dosage form is allowed to sink in the bottom of the vessel. Sinkers are recommended to prevent floating of capsules and other floatable forms. Small loose wire helix may be attracted to such a preparation to prevent them from floating. Reciprocating cylinder apparatus. This apparatus consists of a set of cylindrical flat bottom glass vessels equipped with reciprocating cylinders. Apparatus is particularly used for dissolution testing of controlled release bed type pellet formations. Rotating basket apparatus 1. Sorry, it's the next one. We have done this. Flow through cell apparatus consists of a reservoir for dissolution medium and a pump that forces dissolution medium through the cell, holding the test sample. It must be either closed mode or fluid recirculated, fixed volume, open mode, continuous replenishment of fluids. Advantages of this apparatus: easy maintenance of sink condition, feasibility of large volume, feasibility of automation. Now, fifth one is paddle over the disc. It's an evaluation of transdermal patches, sample holder, or a disc that hold the product. And it is the paddling, total paddling, rotating paddle type apparatus 2. Now, what is cylindrical apparatus? Is used for evaluation of transdermal products with a similar to apparatus 1. Instead of basket, a stainless cylinder is used to hold the sample. It is mounted on a porous cellulose material and adhered to cylindrical. These are all the pictures. If you can see apparatus 1, 2, I will show you 3, 4, 5 and 6, where you can see various forms: reciprocating disc, stirring holder, acrylic rods. So these are all the things what are available for us today. Seventh apparatus, transdermal products, controlled release products. Samples are placed on a disc as shown here. Apparatus 7. The resolution is maintained 32 degrees, 30 cycles per minute. It is a schematic representation of all the experiment we have studied now. Now apparatus 1 is rotating basket for tablets, conventional tablet. Apparatus 2, tablet capsules. Rotating paddle it is, controlled release product suspension. Apparatus 3 is called reciprocating cylinder, controlled release formulation. Apparatus 4 is flow through cell, formulation containing poorly soluble drugs. Apparatus 5, paddle over disc, is for transdermal formulation. Apparatus 6 is cylinder, also for transdermal formulation. Apparatus 7 is reciprocating disc for controlled release formulation. Dissolution methodology for immediate release product based on BCS. BCS class 1 single point NLT 85% Q in 15 minutes. We'll see what is Q and NLT. BCS class 2 multiple point. BCS class 3 same as class 1. BCS class 4 as class 2. Dissolution acceptance criteria. On the basis of dissolution profile, criteria for acceptance of test result is based on Q values. Given in the table, the value of Q defined as percentage of drug content dissolved in a given period of time. Value is generally specified in USP monograph of a given product. Three stages S1, S2, S3 of dissolution testing are allowed as given in the table. The first stage of USP dissolution test consists of testing of 6 dose units. In all the dosage units are greater than or equal to Q plus 5%, then the dissolution test criteria are met and the test is passed. To pass the second stage, the average of 12 dosage unit must be equal to or greater than Q, and no dosing unit can be less than Q minus 15. 12 additional dosage units are evaluated, providing a total of 24 results. To pass the final stage of testing, 24 dosage unit must be greater than Q, not more than 2 dosage form units should be less than Q minus 15. S1, S2, S3 acceptance criteria. First one S1 Q plus 5, Q plus minus 15, or S1 minus S2, dosage is 6, S3 is 12, and S1 plus S2 plus S3 in bracket it will be Q into Q, not more than Q minus 15. So today we have learned what are the various dissolution apparatus and what are the acceptance criteria for the dosage form. The reference is Shagil and Brahmankar as described earlier. Please go through the textbook, read them. So that's all for now. Have a great day. Thank you.